Welcome to the course of differential equation. In this session, we will discuss about second order homogeneous linear differential equation with constant coefficients. We already discussed about second order linear differential equations. That is, we know it is y double dash plus p of x y dash plus q of x y is equal to r of x is the second order linear non-homogeneous differential equation. If this r of x is equal to 0, if this r of x is equal to 0, then we say that this differential equation is homogeneous linear differential equation. This is homogeneous and linear, homogeneous linear second order differential equation. So, homogeneous linear second order differential equation. Okay, fine. Now, our discussion is on the solutions of the second order homogeneous linear differential equation with the constant coefficients. That we discussed it is that maybe this p of x have the choice, also q of x may have the choice, they may be the functions in the independent variable x or the constant values or constant values. Okay, our discussion is on if the values are this one, the values are constant, that is maybe a y double dash plus b y dash plus c y is equal to 0. That may be the second order linear differential equation with the constant coefficients. So, our discussion will move to there, that is we discuss let a y double dash plus b y dash plus c y equal to 0 is the second order linear differential equation with the constant coefficients. Where a not equal to 0, where a not equal to 0 is a non-constant, non-zero constant. Okay, fine. So, definitely our thought is that how can we find the solution of this differential equation? See here, let y is equal to e raised to mx is a solution of equation 2. We just suppose that if maybe y is equal to e raised to mx is a solution of equation 2. So, we say that e raised to mx is a solution of a y double dash plus b y dash plus c y equal to 0. Then we just find y dash is actually m into e raised to mx, and y double dash is there, y double dash is m, we again differentiate y dash with respect to x, therefore, m into m square e raised to mx. So, apply in equation 2, the equation 2 will becomes as, say a y double dash is there. So, a into y double dash is m square e raised to mx, a m square e raised to mx plus now b y dash, b is there, y dash is m e raised to mx. So, plus b m e raised to mx, and finally, we have c, y is there, y is actually e raised to mx. Okay, since we supposed it is that y is equal to e raised to mx is a solution of the differential equation 2. Therefore, that should satisfy the differential equation, therefore, the value will be equal to 0. See, my dear students, here e raised to mx is common in all the terms, we just take it outside, e raised to mx into the remaining parts are a m square is there plus here in second term the b m is there, and in third term c is there, is equal to 0. Say, my dear students, here e raised to mx never be 0. For a non-zero value of m, e raised to mx can have 0 only whenever x tends to minus infinity. So, e raised to mx is not equal to 0. So, the only possibility is that this quadratic part may be 0. This quadratic part may be 0. This quadratic part may be 0. That is am square plus bm plus c equal to 0. Now, see, this is a quadratic equation in M. So, we can find the roots of this quadratic equation. While you are finding the roots of this quadratic equation, we have the formula, it is that ax square plus bx plus c equal to 0. Okay, ax square plus bx plus c equal to 0, then x is equal to minus b plus or minus root of b square minus 4ac by 2a. So, like that we have m is equal to minus b plus or minus root of b square minus 4ac divided by 2a. Okay, here this b square minus 4ac is called the discriminant of this quadratic equation. We know the b square minus 4ac is the discriminant of the quadratic equation. Quadratic equation is the quadratic discriminant of the quadratic equation. So, fine, have the possibilities that is belongs to inside the root. So, that is why maybe b square minus 4ac. B square minus 4ac is greater than 0 if b square minus 4ac, if b square minus 4ac is greater than 0. So, if b square minus 4ac is greater than 0, the value inside the root is greater than 0, therefore, its square root will be the positive. So, there is a value that is equal to b square minus 4ac is positive number, minus b plus a positive number, minus b minus a positive number. So, definitely we will have two different real numbers. Therefore, in this case the roots are the roots of equation 3, quadratic equation 3, the roots of equation 3 are real and distinct, real and distinct. Okay, fine. So, this is the case 1. We can consider this as case 1 for finding the solutions of this quadratic equation. So, we will have whenever b square minus 4ac is greater than 0, the equation 3 has two different roots. On that values of m, this solution will get for the linear differential equation, homogeneous differential equation with constant coefficients. That is ax square ay double dash plus by dash plus cy equal to 0. See, if the in case 2 we can discuss, that is if b square minus 4ac equal to 0. See, my dear students, what will happen in this case? See, b square minus 4ac equal to 0. The term 4ac, b square minus 4ac will be equal to 0. That is, the term inside the square root will be 0. So, this part will not be there. So, the entire m will shrinks into minus b by 2a. The m is equal to minus b by 2a. So, dear students, therefore, we can say that if b square minus 4ac equal to 0, then m is equal to minus b by 2a is a double root. That means m1 and m2 are equal. So, fine, is a double root, and we have one more case, it is here. In case 3, say if b square minus 4ac is less than 0, if b square minus 4ac is less than 0. See, again come back to this formula. So, b square minus 4ac is less than 0. So, there is a negative number inside the root. Therefore, we can say that since inside the root then there is a negative number, therefore, definitely there is an imaginary part, the complex part, imaginary part of complex number will exist there. So, we can say that minus b plus I into a real number divided by 2a minus b minus I into a real number divided by 2a. So, we can say that there is two complex numbers will exist, they are the complex conjugates. So, the roots of, therefore, in this case then the roots of quadratic equation, the roots of the quadratic equation are complex conjugates. The roots of quadratic equation are complex conjugates. Okay, fine. Complex conjugates. So, we have three choices are here. See again, I come back to the quadratic equation am square plus bm plus c equal to 0. See, this is what is called the auxiliary equation. This quadratic equation is called the auxiliary equation. Auxiliary equation or characteristic equation of the given differential equation, that is a differential equation with the constant coefficients, that is ay dash plus by equal to 0 is here. So, definitely, so we have, while what we got here, it is that whenever we substituted y is equal to e raised to mx is a solution of a differential equation, then we got here the values of m. There are three choices to get the solution. Maybe m may be real and distinct, therefore, choice of solution are 2. If they are real and distinct, they have two kinds of the solution, that is m1, m2 may exist. On the case, we can say that y is equal to e raised to m1x, y is equal to e raised to m1x, and y we can say y1, and y2 equal to e raised to y2 equal to e raised to m2 of x are the solutions. Since m1 and m2 are distinct values, so definitely we can say that since m1 and m2 are distinct values, these are linearly independent functions. These are the linearly independent. These are the linearly independent functions. These are the linearly independent functions. These are the linearly independent functions. Since they are linearly independent functions, they are the solution of a second order homogeneous linear differential equation. So, according to the fundamental theorem that we discussed in previous session, so their linear combination is the general solution. So, we can say that. So, in case 1, say in case 1 we can say that, therefore, in case 1 the solution of the differential equation, ay double dash plus by dash plus cy equal to 0 is, y is equal to c1 e raised to m1 of x plus c2 e raised to m2 of x is the general solution, is the general solution of equation number 2, is the general solution of equation number 2. Okay, fine. So, see how can we solve a second order linear differential equation with constant coefficients. So, we just evaluate. Firstly, we evaluate. We can find an auxiliary equation corresponding to every second order linear differential equation with constant coefficients. From that auxiliary equation, we can find the value of m if the value of m are real and distinct. If the value of m are real and distinct, then we can say that, see, if the value of m are real and distinct, then we can say that e raised to m1x and e raised to m2x are two linearly independent solutions of the differential equation. So, they will form a basis, they will form a fundamental system for the differential equation. Since they are the basis and fundamental system, as according to a theorem that we discussed before, we can say that y is equal to c1 e raised to m1x plus c2 e raised to m2 of x is the general solution of the differential equation. Okay, we can discuss it with some examples. In example 1, see, solve the differential equation, y double dash plus y dash minus 2y is equal to 0. Suppose this is the equation number 1. Okay, y double dash plus y dash minus 2y is equal to 0. So, my dear students, this is a differential equation. First of all, to evaluate the solution, to find the solution, we just write the auxiliary equation. The auxiliary equation of 1 is, that is ay double dash, that is am square. Here value of a is equal to 1, b is equal to 1, c is equal to minus 2. Okay. So, we can say that am square, that is equal to m square plus bm minus 2, am square plus bm plus c equal to 0. So, just we can find the values. For the simplicity, I would like to consider this is equal to evaluate quadratic equation. We know x square x square plus bx plus c equal to 0. While multiplying, we just take if m1 and m2 are the values, m1 plus m2 equal to b, m1 plus m2 is equal to b and m1 into m2 is equal to c, then we say that this is equal to minus m1 and minus m2 are zeros of the quadratic equation. Okay, similarly, I would like to discuss it is that, see, here we have the values, instead of c we have the values is equal to 2, and instead of b we have the value 1. Okay, fine. C is equal to minus 2. See, while multiplying two values, you have to get the value is equal to minus 2. That is equal to, I would like to multiply, this is equal to minus 1 into 2. The value will be is equal to minus 2. Minus 1 plus 2. The minus 1 plus 2, the value will be equal to 1. So, minus 1 into 2 is equal to c, and minus 1 plus 2 is equal to b. Okay, fine. Therefore, we can write this is instead of this equation, we can write. So, we can say that m square plus m minus 2, m square plus m minus 2 equal to 0 is the quadratic equation that can be rewrite as m, the value is equal to m minus 1 into m plus 2 equal to 0. M minus 1 into m plus 2 equal to 0. Say just you can check whether it is right or wrong by using this concept m into m square, say m into m is m square, m square, and m into plus 2, that is equal to plus 2m, m into minus 1, that is equal to minus m into minus 1 is equal to minus m, okay, fine, and m into minus 1 into 2 minus 2 equal to 0. See, my dear students, m square plus 2m minus m plus m minus 2 equal to 0. See, that you can understood from here. Okay, no problem. Therefore, we can say that this is equal to, okay, fine, m square m minus 1 into m plus 2 equal to 0. See, from here we can say that is m minus 1 equal to 0 or m plus 2 equal to 0 or both are equal to 0. That is m is equal to 1, okay, or m is equal to minus 2, fine. Okay, we found the values of m. We found the values of m. They are real and distinct. They are the real values and distinct values. Fine. See, dear students, so as according to this, the real and distinct values for m, therefore, we have the format of general solution. Therefore, general solution is y is equal to y is equal to c1 e raised to m1x plus c2 e raised to m2 of x. Okay. Therefore, y is equal to c1 e raised to m1 of x, m1 is a 1. So, e raised to m1 of x is x plus c2 e raised to m2 of x, here m2 is equal to minus 2, e raised to minus 2x. So, is the general solution of given differential equation, that is all. So, now we found the general solution. So, this is our general solution of given differential equation. See, my dear students, here we found the general solution for the differential equation. So, we found the general solution of differential equation. Here C1 and C2 are the arbitrary constants. So, maybe if it is initial value problem, the initial condition will be there. If the initial conditions are there, if we apply the initial condition in this general solution, we can find out the particular values for C1 and C2. So, from there we will get a particular solution. Okay, we can move one more example. See, in this example, example 2, solve an IVP, initial value problem. Solve an IVP, y double dash minus y dash, y double dash minus y dash minus 2, sorry, y dash minus 2y equal to 0, minus 2y equal to 0. See, y of 0 equal to 0 and y dash of 0 equal to 1. Y of 0 equal to 0, y dash of 0 equal to 1. Okay, this differential equation with the initial condition, therefore, that is an IVP, initial value problem. To find the solution, firstly we find the auxiliary equation. Auxiliary equation. See, what is the auxiliary equation? We started the differential equation with the values a is equal to 1, b is equal to minus 1, c is equal to minus 2. See, dear students, this is a differential equation, therefore, we can write the auxiliary equation a m square, that is m square plus b m minus m minus 2 equal to 0. As I said you before, maybe you can use the formula m is equal to minus b plus or minus root of b square minus 4ac by 2a. Okay, you can apply all the values, no problem. But maybe simply we can consider the values, two values. There some will be the coefficient of m, the product will be the constant term. So, that values are see the values that is equal to -2 plus 1 equal to -1. That is the coefficient of m, and -2 into 1 is equal to -2. That is the product of -2 into 1 is equal to -2, the constant term is there. So, simply we can write, instead of this we can write, okay, simply we can write this is equal to, this equation can be factorized as m minus 2 into m plus 1, okay, is equal to 0. Fine, from here we can write this is equal to, this implies either m minus 2 equal to 0 or m plus 1 equal to 0, or both are zeros. Fine, from m minus 2 equal to 0 we found the value of m is equal to 2, and we the other value will be m plus 1 equal to 0 implies m is equal to -1. Okay, fine. Therefore, m is equal to 2 and m is equal to -1. M is equal to 2 and m is equal to -1. That is, we can simply we can say that m1 equal to 2 and m2 equal to -1. Therefore, general solution is y is equal to c1 e raised to m1x plus c2 e raised to m2 of x. Fine. So, this is equal to, that is y is equal to c1 e raised to m1x is e raised to 2x plus c2 e raised to -1 into x minus x, is the general solution of the differential equation, is the general solution of the differential equation, is the general solution of the differential equation. Okay. Fine. See, we have initial condition in this question, given that y of 0 equal to 0 and y dash of 0 equal to 1. So, we can apply the initial condition, therefore, we will get the particular values for C1 and C2, hence then we can find the particular solution for this question. So, apply the initial condition, apply the initial conditions ICs. Okay, given that y of 0 equal to 0 and y dash of 0 equal to 1. Okay, y of 0 equal to 0 and y dash of 0 equal to 1. Fine. See, here we have general solution is c1 e raised to 2x plus c2 e raised to -x, y of 0 equal to 0. Okay, fine. So, we have y of 0 equal to 0 means that is equal to y is equal to, see, just a minute, y is equal to c1 e raised to 2x plus c2 e raised to -x is there. So, y of 0 equal to 0, 0 equal to c1 e raised to 0 plus c2 e raised to -0 is 0 is there. Therefore, we found c1 plus c2 equal to 0. Just we mark it as this is equation number A. Okay. Just we mark it as this is equation number A. Now, we can differentiate this y. So, while differentiating y dash is equal to c1 e raised to 2x is there. Therefore, while differentiating this is 2 c1 e raised to 2x plus c2 e raised to -x is there, derivative of -x is minus e raised to -x, minus c2 e raised to -x is there. So, y dash of 0 equal to 1 is the second initial condition. Apply here, therefore, y dash of 0 equal to 1, y dash of 0 equal to 1. Therefore, 1 is equal to 2 c1 e raised to 0 is 0 minus c2 e raised to 0 is 0. Therefore, we have the equation 2 c1 minus c2 is equal to 1 is the second equation. We just put it as the equation number B. while solving A and B, we will have the value of, we can find the value of C1 and C2. See, we have the equation is C1 plus C2 equal to 0. Okay, C1 plus C2 equal to 0. This is we put the equation A, and 2C1 minus C2 equal to 2C1 minus C2 equal to C1. That is the equation B. That is the equation B. Okay, fine. Now we can solve this. So just we can do while summing A and B, we can remove C2 from there. Okay, so we just do A plus B, C1 plus 2C1, that is actually 3C1, C2 plus minus C2 is 0, and finally here we have value is equal to 1. Therefore, C1 is equal to 1 by 3. Okay, put in A, this implies C1 1 by 3 plus C2 equal to 0, this implies C2 equal to minus 1 by 3, C2 equal to minus 1 by 3. Okay, fine. Okay, then same idea students, we found C1 equal to 1 by 3 and C2 equal to minus 1 by 3. Therefore, the particular solution of the differential equation is, we have this is equal to C1 e raised to 2x plus C2 e raised to minus 6. Therefore, the particular solution of differential equation is, therefore, particular solution of given initial value problem is y is equal to C1, that is 1 by 3 e raised to 2x minus 1 by 3, C2 is minus 1 by 3 e raised to minus 6. Okay. So, maybe we can write this is the particular solution, maybe we can write this is equal to 1 by 3 into e raised to 2x minus e raised to minus 6 is the particular solution. Okay, that is all. So, while finding the roots of a second order linear homogeneous differential equation with a constant coefficient, we just write the auxiliary equation. And after writing the auxiliary equation, we have to find the roots of the auxiliary equation. If the roots of the auxiliary equations are real and distinct, then we can say that the general solution is C1 e raised to m1x plus C2 e raised to m2fx. m1 m2 are the two real and distinct roots. So, that is why we can say that if the problem is initial value problem, we can find the particular values of C1 and C2, and we will have a particular solution for that differential equation. Okay, just write down one more exercise for you. First one, solve y double dash minus 5y dash plus 6y is equal to 0. Similarly, the second one, solve y double dash minus 8y dash plus 16 is equal to 0. Okay. Try to solve this two problems. You can very much understood about the how can we find the solution of a second order linear homogeneous differential equation. Thank you for watching this video. Continue watching. Thank you very much.